All right, first things first, let me open the template. So I'll copy everything. And with here, I'll delete the old original template and paste the one that we use. So we have everything here set up, all the functions that we need for the robot to check the distance between the sensor and any object in front of it. We have the functions to check if the left tracker is on the black line, same with the right. And we have the functions that will allow us to tell the robot to move forward, reverse, left, right, and so on and so forth. So as you can see, there is nothing in the loop function. And first things first, the first task of the robot is to be able to move along the line, along the track, using only the right line tracker. So let's check. So this will be the left, and that will be the right line tracker. So we'll only use the right line tracker and make the robot follow the line. And the idea is for the robot to always end up seeing the black line using the right line tracker. And to do that, we have to make the robot move forward, but should lean to the left. For that, I'll scroll down and find the function for forward. There. I'm going to make a duplicate copy of this function. But instead, I'm going to name it forward left. And then, so forward is still there. But for forward left, for the robot to move forward and lean to the left as it moves forward, I need to make the left motor run a little bit slower. So probably I'll just move or remove around 10% of the power so that the left motor will move slower. Let's check that out. So here, I'll just make the robot move forward, left. So instead of using forward, I will use forward, left at 40%. So what do we mean by 40%? Remember that our battery is 9 volts. So 9 times 0.4 or 40% is around 3.6 volts. That should be enough for the robot to be able to move forward. Not too fast, not too slow. Maybe just enough. We'll make adjustments later if there is a need to adjust. So 40%, but it should move towards the left. And I'll make further changes here so that if and while the right tracker is equal to 1, once the right line tracker is on the line, it should make changes or corrections by making the robot move to the right at 40% power. And should stop after 1 millisecond. It doesn't really matter about the time, since it will keep on moving to the right as long as, or while the right tracker is on the black line. So it will make adjustments and make sure that the right line tracker moves away from the line whenever it encounters it. The movement will be, the robot's movement will be towards the left and then move away towards the right. So let's find out if this will work. So the first task is to make the robot follow the line using only the right line tracker. I'm going to upload. So let me just check the connection. So board is Arduino Nano. Port is port 6 in my case. And processor is either 80MB328P or the old bootloader, whichever works. I will upload. I will not save. I'll probably save there. One was not declared. Okay, that is a mistype. So I'll Load again. If uploaded, let me check if this will work. I'll remove the cable and switch it on to move forward and make sure that it stays along the line. So look at the movement. So we can say we are successful at that part, in that part, or in that particular task. Okay, stop. Next. Remember that we are only using the right line tracker. Basically, because we have plans for the left line tracker, we will actually use the left line tracker to count the number of lines it will encounter along the way. And to do that, we have to set up some variables. In this case, I'll go back here in the declarations area, and I'm going to declare a variable named max stations, so that max stations, just to keep track of the total number of stations that I have there. So I have a total of 5. This will be 0 starting station. This will be 1, 2, 3, 4, and 5. And then again 0, 1, 2, 3, 4, and 5. And then 0. So a total of 5 stations, excluding 0. So I'll put it there. And then I'm going to create another variable named station is equal to 0. Starting station is 0. I'll make use of this variable to check or to update the location of the robot while it moves along the line. And then I'm also going to create a variable named target station, which I will use later to tell the robot where to go. The target station is currently set to 0. And to test, I need the robot to move along the line and stop on the 6th station, or if after moving past the 5th station. So let me put the code here and say, so as the robot moves along the line or along the path, if the robot sees a black line using the left line tracker, if left tracker is equal to 1, then what I want to do is for the robot to count that particular line. But remember that the line is a bit wide, so I need the robot to make sure that that line will be counted only as 1. So before counting 1, I want the robot to move as long as the left tracker is still equal to 1. So forward, continue moving forward. Left, 40% power. And only count after moving past line, plus 1. Okay. So station, whatever is the value of station, plus 1, that will be it. So this only happens if the left tracker is on the black line, and once it happens, it will continue moving past the black line and then count. And maybe to signify that a line was detected, I'll make it beep for a while. Beep for a short period of time, probably 100 milliseconds. I'm not sure if you will be able to hear it there, but I'll just make it beep. And then afterwards, I'll make it stop. So, while station is equal to 6, once it reaches 6, it should stop. That will be the code for making it stop once it reaches number 6. Let's find out if this will work. Let's upload. There, let's find out. The robot should start moving from this point and stop once it returns. I'll switch it on. 1, 2, 3, 4, 5, 6. It's stop. Let's try it again. Reset. Move. 1, 2, 3, 4, 5, and 6. So we're successful. The robot is now able to count the number of lines along the way using only the left line tracker. So next is we need the robot to stand by at the very beginning and wait for us to press a key or any button on top of the cover. So what I'll do is I'll switch it off. I'll plug it in first. And I'll make changes to the code first. I'm going to improve how I organize code by removing this part first. This is just for testing purposes. I'll delete it. And then I'm going to move this somewhere else. Cut. I'll put it somewhere. I will name this function check station. And I'll put the code there instead. And here, put there the name of that function. So the robot will move forward and left, and then while it moves, it will check the station. There. So the details on how the robot will check the station is found here. I'll probably make some changes here and set probably put here if station is greater than max stations, then station should be reset to 0. Just remember, station 0 should be station 0, and if the robot moves past station number 5, we should reset the station number to 0. So here, so before moving, what we need to do is to make the robot stand by, wait for instructions when to move. And we'll do that by using the buttons already installed on the robot. And we'll have to make some do additional setup here. I'm going to declare additional variables. We put here constant b1 constant by b1 is equal to pin number 7. So I'll just make a copy. This will be for b2, b3, b4, b5. This is 8, 9, no, that is 11. Based on our activity before, this is 12, this is 14. So make sure that your connection for the button should follow the following. Button 1, 7, button 2, 8, then followed by 3, 11, for 4, 12, 5 is 14. And then here, I need to set up the pin mode for each button. So pin mode for button 1 is input pull up. So when we do that, the pins 7, 8, 11, 12, and 14 will be always high all the time. So this will be for button 2, this is for 3, this is for 4, for 5. Okay, so all button pins will be set to high at all times. And here in standby, the robot should avoid stand by. So first things first. So while station the robot is in station number 0 and target station is also equal to 0. So there are two conditions here. Take note of this one, operator. This means and. So this should be true, and this should be also true for this to work. So if one of the conditions becomes false, then this will return false. So the robot will stop as long as stations is 0 and target station is 0. And you will check if one of the buttons, B1 to B5, is low. If it's low, then we are sure that the button is currently pressed. So digital read B1. Okay, so digital read B1. If it's equal to low, then it's currently being pressed. If it's being pressed, then just set the target station to 1. If not, then do nothing. Let's do the same for the second button. Let's do the same for the third. For the fourth. And for the fifth. And then probably, let me just check my code. So this is the beginning of the while. And I may have deleted the end marker for a while, so that's the end. Okay. There. So take note of your open and closing brackets. And the closing bracket for this one is over, oops, over there. Okay. And then I'm also going to add some delay in between button presses for probably around 100 milliseconds. Okay. Now, so the robot should stay on standby as long as station is equal to 0 and target is equal to 0. And then it should wait. Okay. And then so the robot should move once I press a button. And when it moves and checks the station, it should simulate that it is doing delivery or pickup while it has reached the destination. So I'll go to check station, and here I'm going to check if the station is equal to target station. If it is, I'm going to make the robot stop. Oops. Okay, and do a simulation. So stop, and then probably make the robot switch on its LED on. And then I'm going to make it beep for say 1 second. And wait there for 2 seconds and switch off the LED. And set target station to 0 before it moves back to station 0. So once it goes back to station 0, it should stop there. Okay, let's find out if this will work. Load. So there's a typo there. Load again. Approving. Done. Let's find out if this will work. I'll switch it on. The robot is not moving. Currently, it's on standby. I'm going to press number 2, which would mean that the target station will be number 2. This is 1, 2, 3, 4, and 5, and then back to 0. So I'll press number 2. That's 1. That's 2. Stop. And it stays there for a while, and it goes back again to station number 0. And just stop there. And again, wait for me to press a key. So if I say, or if I press button number 5, the robot should move again and stop here. So I'll press number 5. So that would be 1, 2, 3, 4, and 5. And wait, and then go back. So remember that whenever the robot reaches the target station, it is basically just doing a simulation that is doing a delivery or pickup. So it's waiting again. One last check. I'll make it move to station number 3. That will be that station. 1, 2, and 3. 1, 2, 3. Stop. Do a simulation, then it should now go back to the home base. And that's it.